Hello, my name is Isaac Edmund Fonseca, and my FYRP topic, which I'll be presenting today, is the removal of color from water using activated charcoal. My supervisor throughout my FLP will be Muhammad Elfi Mersal. So to begin, I will give a brief explanation on what activated charcoal actually is. Activated charcoal is a charcoal. Activated charcoal is charcoal that goes through an activation process, which turns it into a fine and odorless black powder. The activation process greatly increases the surface area of the charcoal through superheating natural sources of carbon, such as coconut husks, wood chips, or sawdust. Activated charcoal, or also known as activated carbon sometimes, have very adsorbent properties, allowing it to bind to molecules, ions, and atoms easily. Not to be confused with absorption. Absorption. Adsorption is an exothermic process based on the surface area of the adsorbent agent, while absorption is an endothermic process that includes the total volume of the absorbent agent. Uh, the problem or the problem statement of my research topic is that a lot of rivers in Sarawak are heavily polluted, that their colors change to reddish or brownish. So a few questions that I have to ask while conducting my research is, can activated charcoal decolor water? Is the product environmentally friendly? And is it locally available? So the aim of this research topic is to investigate the decolorization of polluted water using activated charcoal, and my objectives will be to answer those questions that I have stated earlier. The significance of this report is that activated charcoal is such a great water filter due to it being natural and effective at removing unwanted materials and toxins in water. Uh, these toxins can include volatile organic compounds and also chlorine. Utilizing activated charcoal can be an easy approach to cleaning rivers in Sarawak that are heavily discolored. This, the discolorization of water is due to dyes and other waste from industries that pollute nearby water. The heaviest contributors towards the pollution are textile companies, dye manufacturing companies, paper and pulp mills, also food distilleries, which can be found all over Sarawak. Excuse me. Therefore, conducting this research can greatly benefit the environment for cleaner water resources. So for my literature review, the picture on the right shows the molecular structure of activated charcoal. As you can see, there are a lot of holes, and I'll talk about this in a bit. So there are four main topics that I would like to talk about. First of all being the effectiveness, and then the effects, cost effectiveness, and the local availability of activated charcoal. So activated charcoal is the most used absorbent to decolor wastewater around the world. This is because of the highly porous and great surface area of the molecular structure found in activated charcoal, as I mentioned in the picture. This makes the material very reactive to attracting pollutants and toxins in the water. Once these pollutants bind with charcoal, they cannot be released and will eventually fill up all the gaps available. So after a while, depending on how polluted the water is, the charcoal will need to be replaced, and there are several ways to handle this issue, which I will talk about later in the presentation. So secondly, the effects of activated charcoal on the environment. Uh, Effects on the environment are little to none. This is because activated charcoal is a carbon compound that is made from natural carbon resources, and proper disposal or treatment of the material will not leave any pollution behind, as most of the pollutants and toxins that captured will be organic based. The activated charcoal can be reactivated through the same process as I mentioned before, the activation process, which is basically just superheating it to eradicate all the pollutants that were trapped inside before. So this will all be gone. This allows manufacturers and or companies to reuse the activated charcoal as a filter again. So That is one way to reduce waste, which is of course good to the environment. Removing color from natural bodies of water is also very important to maintain the health of the ecosystem. So very reddish or brownish colored water must be treated, as these waters contain a lot of toxins which can be harmful towards both humans, plants and animals, and anything alive. Following that, the cost effectiveness of activated charcoal as a water filter can be very beneficial. As I have mentioned before, it can be reused when treated correctly. Another way of treatment besides the reactivation process is using the used activated charcoal as fuel to fire cement kilns or any other significant heat source. A big factor that affects the cost of activated charcoal is although the activation process can be very costly, the materials needed for it can be found in abundance as waste from the agricultural industry here in Sarawak. So these materials can include sawdust, wood chips, and coconut husks, which I have mentioned earlier. All this can be used to create activated charcoal as well. Continuing my last point, since all these waste materials are natural carbon resources and can be found abundantly in Sarawak, the local availability is a no-brainer. So it can be easily manufactured locally here in Sarawak. So moving on to my methodology. In the flowchart, you can see my methodology for my research topic, so for my FYPR1 and also a bit of my FYPR2. So after conducting research, which I am doing currently, I will plan out experiments based on research papers that have already been done in the past, mainly focusing on ones that use activated charcoal as a water filtration method. So following that, I plan to obtain at least 3 water samples of maybe different colors or intensity to experiment on from the local rivers in Kuching. Then I will mix the activated charcoal in varying quantities for each sample to see what are the effects of the amount of activated charcoal used on the decolorization time and also effectiveness. So maybe using more will decolor the water faster, or maybe decolor the water even more compared to using less, if that makes sense. There are 2 ways to obtain data from these experiments. Ideally, I would have access to a spectrophotometer to accurately compare the results in each water sample. However, if I cannot get my hands on one, I will have to compare the water samples by eye. If I do the comparisons by eye, I have to ensure that every other factor that I can control be controlled and be as constant as possible, such as lighting and all that. A spectrophotometer is an instrument that measures the amount of photons that passes through a sample solution. So basically, just measuring the intensity of light that passes through the solution. So after gathering all the data, proper discussion on the findings will be conducted to come up with a defining conclusion. For my future plans, in the upcoming semester break, I plan to start finding more water sources to collect samples from. So far, I've only found one. I found a stream in Matang, which is very reddish in color, and I plan to find at least 2 more before planning out my experiments and settling and finally finalizing my lab procedures. After that, I will go to local chemical laboratories that will grant me access to use a spectrophotometer. If not, then I will have to use the other method that I have mentioned, which is by eye. Hopefully, I will finish all my experiments by the end of the semester break, and I can start discussing my findings by the start of semester 2. So that is all from my presentation today. But before I leave, I would like to thank my supervisor, Muhammad Elfi Masal, for his guidance and support throughout the semester and helping me plan my progress throughout my FYRP1. Thank you very much.